Have to put my favorite student on here, good old Anne. Alrighty. Examine this graph. Stop. As soon as I see a graph, I'm always asking myself, Mina, what kind of a graph is this? The two you're going to see on your test are distance versus time and velocity versus time. Key ideas. Are you ready? On a distance versus time graph, how can I figure out the speed or velocity? Looking for a word. Slope. On a velocity versus time graph, what does the slope tell me? Acceleration. Okay, you need to know that. You need to know that. So, and on a distance versus time graph, number one is asking how far. How far is the height? So how far is the truck from its starting point after 10 seconds? 300 meters. On a test, if you just wrote 300, I'd take a half mark off. Units, please. How far is it after 15 seconds? You know what? Still 300 meters. How far is it after 30 seconds? 200 meters. After 45 seconds, that's right there, halfway between 600 and 800. 700. So I think it's fair game for me to ask you to kind of extrapolate values between. 50 seconds, 800. So that question's out of 5, 1 mark each. Now, truck's velocity over each of the intervals. Really, I'm talking about the slope. So the velocity over this first interval is going to be the rise over the run. It's going to be 300 divided by 10, 30 meters per second. Interval B, oh, you know what? It's at rest, 0 meters per second. How did I do that so fast? I know horizontal line has a slope of 0. C, first thing I did is I put a negative there just so I wouldn't forget. It's going backwards. Now, here, it's 300. Here, it's 200. The rise is 100. The run is 10 seconds. You know what? You're going negative 10 meters per second or 10 meters per second backwards. I've already told you I prefer just to say a negative. D. Oh, this one's going to be a bit trickier. 200, 600. The rise is 400. The run is still 10 seconds. So 40 meters per second. And interval E goes from 600 to 800. The rise is 200 over. The run is 10, 20 meters per second. 1 mark for each of those. So that question is also out of 5. Next page, circle the correct answers. They give me a graph. What kind of a graph is this? Distance versus time. So the height is how far. The slope is how fast. Steepness up means forward. Steepness down means backwards. And steeper means faster. So A is, what'd you say for section A? Speeding up, slowing down, or constant speed? What'd you say? Speeding up, slowing down, or constant speed? What'd you say? Speeding up, slowing down, or constant speed? I'm going to repeat myself until someone gives me an answer. Sorry? Ooh. Someone said speeding up. Someone said constant speed. What would speeding up look like on a distance time graph, Sally? The steepness has to be getting steeper, right? Good. Now, Sally, look up. You would be right if instead of distance time, it was speed time. That would be speeding up. And that's the tricky part. Again, I think I've said this, but I'll repeat myself. Really, all I've taught you so far this unit is a repeat of Math 10. We've been doing rise over run, rise over run, rise over run, rise over run. Oh, and we plugged a couple of equations in. So, constant speed, 1 mark. A is moving forward or backward? Forward? What would backward look like on a distance time graph? Downhill. B is moving faster than or slower than? How do you know? Less steep. So that question's out of 3. True or false? Oh, stop. It's a graph. What kind of a graph is this? Distance versus time. True or false? This object is at rest at interval C. I think false. It's moving forwards. But true, interval D. That's at rest. Now, look up. Don't write this down. What if it was a velocity time graph? I'm asking, would true or false, are we at rest in interval C? True or false, are we at rest in interval D? What does at rest look like on a velocity time graph? It's still a horizontal line, but Parmjot, there's something else. What was that supposed to mean? It's on the x-axis, right? 0 high. Here, on a velocity time, this is speeding up because the velocity is getting higher. What interval is the object at rest? It's a distance versus time graph, interval G. When is this object traveling the fastest? I think F, yes, is the steepest. It's a little steeper than H. Turn the page. A lot of people ask me, Mr. Duick, how do I find the average speed? The average speed, look up, would be the slope of that line right there. I'm not going to draw it because it gums up my whole graph. But it would be the slope of that line right there. But the other way you can realize that is you can still use v equals distance over time, because average speed for the whole trip is going to be the total distance, which is 25, and the total time, which is 22, which also does happen to be the rise over the run. And I have no idea what this is. 25 divided by 22. And I should probably go to 2 sig figs, so I'm going to say 1.1. If you said 1.14, I'm okay with that. If you said 1.13, I'd take a half mark off because it's not 1.13. Round off properly, please. So I'm going to go 1.1, and it looks like it's meters per second because that's what's on the y and x axis. 1 mark. Average speed for each of the following intervals, well, it's going to be the slope for that right there, which is 5 over 2. That I can do in my head, 2.5 meters per second. From 4 to 8, it's going to be the slope of that chunk right there. That I can do in my head, 0 meters per second. 14 to 18, this one was yuckier. 14 is there, 18 is there. I chose to let the rise be 20 minus, I used 12.5 because it was roughly halfway between 10 and 15. If you use 13, I'm fine with that. Heck, if you use 12.4, I'd look at you strangely, but I'd say, you know what? We're guessing anyways, so I'd take that. The run is definitely, 2 from 14 seconds to 18 seconds. I can do that in my head. So I'll show you what I got, and then I'll tell you the range of values that I would take. I got 14. Thank you. Like I said, the run is 4, 4, 4. Whoops, bad math in my head, Mr. Duick. So I got 1.9. I'd take 1.8, 1.7. I'd take 2. Anybody get anything else different? So I'm going to go 1.9. Oh, I'd take 1.875 too, but I'll go 2 sig figs because it's really, we're guessing. 6 to 17. Okay. 6 seconds is right there. 17 seconds is right there. It's going to be the slope of that line. Well, that's 5. That's 15. I think the rise is 10. The run, Jaden, I believe, is 17 take away 6, 11. And I think you get 0.91 meters per second. You get 0.90909090. So 0.90 repeating 0.9. I'd take that. I'll go 0.91. Now, how do I know when I have to lay my ruler down and do that tangent line thing? The trigger phrase for that, Mina, is instantaneous speed. Oh, and probably the graph has curves on it, like this one does. I'm only going to give you one instantaneous speed question on your test, and the reason is, Jordan, because you're having to eyeball it with your ruler, there's such a wide range of values, it's frustrating for me to mark. So on your test, though, there will be one graph with curves, and I'll give you a point, and I'll say, tell me the instantaneous slope right there. Here, I said at 12 seconds, so I'm going to put a little dot right at 12 seconds, and then I'm going to lay my ruler down and eyeball that slope. I think it's about that-ish, kind of, sort of. And again, Josh, you may be a little bit steeper. Sarah, you may be a bit shallower. I'm getting, let me go rise over run here. Well, I think I'm going to try maybe using that point and that point, maybe. So I'm getting a rise over run of around 25 is the rise from 0 to 25, and the run is from 8 to 18. I'm getting around 10. I'm getting around, is it around 2.5-ish, 2.3? In fact, I'd probably take anything between about 2.1 and 2.9. Sorry?
I got like
5? 4? You know, I'd probably take it. Part of it also is I shrunk this graph down, which makes it tougher, which is why I kind of decided not to count this. Yeah. 1.5? So what you really want to look at is the line that you drew. Does it look about as steep as my line? A little steeper. Then you did slope wrong, because if your line is steeper, your numbers should be higher than mine, not smaller. Now here's the key. Don't count squares. In other words, if you went 1, 2, 3, 4, 5 squares over 1, 2, 3, 4, 5. That would give you a slope of 1. Each square is not worth 1. This is why I keep yelling at you folks. Read across onto the axis. Read down onto the axis and get your actual numbers. So show me, if you got something really different, show me your work a bit later. Last one. 16 seconds. Okay, I'll do that one in black just so I can leave them both on here. 16 seconds is right there. I can already tell you it's going to be shallower, less slope. To me, mine looks about that steep-ish. I'm going to use, I think, this point right here and this point right here. So my rise is 5, 1 square vertically, and my run is between 4 and 20. 16? 4 and 20? Yeah, 16. So I'm getting around 0.3. I'd probably take anything between about 0.18 and 0.4 or 5-ish. 0.31 meters per second. So if you got way off from my two values, in a few minutes, just come bring your quiz up and we'll look at it and see if you zigged somewhere or whether I'd take it. I'm not going to count this one. This is for your own personal edification. You can, if you want to, give yourself a score of 24. I'm not going to collect this one. What is due next class, for sure, is quiz 5. You are going to get a bit of homework this weekend if you don't get it done today or during Flex or, yeah. Okay, let me just pause the video.